செய்திக் கதம்பம்.
இன்றைய செய்திக் கதம்பத்தில் சமூக வலைதள பதிவுகள் மற்றும் சென்னையில் நடைபெற்ற சிஎஸ்ஐஆர் கட்டுமான பொறியியல் ஆராய்ச்சி நிறுவனத்தின் வைரவிழா நிகழ்ச்சியில் நித்தி ஆயோக் உறுப்பினர் டாக்டர் விஜயகுமார் சரஸ்வத் பங்கேற்று பேசிய உரை ஆகியவை இடம்பெறுகின்றன. முதலில் சமூக வலைதள பதிவுகள். குடியரசுத் தலைவர் திருமதி திரௌபதி முர்முவை மொரீஷியஸ் பிரதமர் திரு பிரவிந்த்குமார் ஜுக்நாத் தில்லி குடியரசுத் தலைவர் மாளிகையில் சந்தித்து பேசினார். தொலைபேசி மூலம் வாழ்த்து கூறிய ஓமன் மன்னர் ஹெய்தம் பின் தாரிக்குக்கு பிரதமர் திரு நரேந்திர மோடி நன்றி தெரிவித்துள்ளார். இந்தியா ஓமன் இடையேயான நூற்றாண்டுகால உறவுகள் மேலும் புதிய உச்சங்களை அடையும் என்று பிரதமர் கூறியுள்ளார். மத்திய வெளியுறவுத்துறை அமைச்சராக பொறுப்பேற்றுக் கொண்ட டாக்டர் ஜெய்சங்கருக்கு இங்கிலாந்து வெளியுறவுத்துறை அமைச்சர் திரு டேவிட் கேமரூன் வாழ்த்து தெரிவித்துள்ளார். இதற்கு நன்றி தெரிவித்துள்ள டாக்டர் ஜெய்சங்கர், இரு நாடுகளுக்கும் இடையேயான உறவு வலிமையானது என்று கூறியுள்ளார். நாட்டின் முன்னேற்றம் மற்றும் மக்களின் வாழ்வில் சுகாதாரத்துறை முக்கிய பங்கு வகிப்பதாக அத்துறைக்கான அமைச்சர் திரு ஜே பி நட்டா கூறியுள்ளார். சென்னையில் நேற்று சிஎஸ்ஐஆரின் கீழ் செயல்படும் கட்டுமான பொறியியல் ஆராய்ச்சி நிறுவனத்தின் 60வது நிறுவன தினம் மற்றும் வைரவிழா நிகழ்ச்சி நடைபெற்றது. இந்நிகழ்ச்சியில் சிறப்பு விருந்தினராக கலந்து கொண்டு உரையாற்றினார் நித்தி ஆயோக் உறுப்பினர் டாக்டர் விஜயகுமார் சரஸ்வத். அவர் பேசும்போது,
Let us just talk about what is the structural health monitoring system. In aerospace, I come from aerospace area, so we used to do the structural health monitoring of the aerostructures. And we developed our own specific methods of doing that. And when I was preparing this talk, I found there are lots of similarities what is being done here. You have the structural health monitoring strategy, which could be a global monitoring strategy or it could be a local monitoring strategy, which depends upon what are the physical parameters you are wanting to measure and what are the sensors associated for making the measurements. For example, the acoustic emissions, you use piezometric sensors. Deformation and displacement, you use deformation displacement sensors. For frequency, mode shape and dynamic stability, you use acceleration measurement or deflection monitoring. For physical integrity, you use photogrammetry and delamination spalling, like that, corrosion, electrochemical methods and so on. So these are the systems which are to be integrated and they become part of your SHM process. Application today in all this is going to be mainly through the artificial intelligence. AI can enhance structural health monitoring by two methods. Number one, image-based SHM, like I mentioned to you, and the vibration signal-based SHM. If you take inputs from somewhere, whichever structure you are taking, then you put through a machine learning method where you have done the supervised learning or the unsupervised learning, or you have done the reinforced learning, and then you get the output that would be sent for that. And the mechanism, like for example, here what we have shown, there's a building which has been affected by earthquake. You take a image of that portion, and that image you do extraction of the features. Now you have a data set coming from the database, use the ML methods, integrate with that, and come up with the predictive method, and that will give you the seismic peak drift ratio, what will be important for that. So all these challenges, streamlining the processes, there are new ways to tackle. Generative design revolution, AI-driven algorithms can actively generate multiple design options. It accelerates the design process by producing innovative solutions. AI-enhanced simulation and analysis certainly leads to smarter, quicker, and more accurate outcomes. And collaborative tools, it can help all stakeholders brainstorm ideas, offer design suggestions, and predict potential challenges. There are top structural engineering trends which are there. Dr. Gomti Nagam did mention about IoT. It changes the way buildings are designed, constructed, and managed today. Basically, if you look at this kind of a structure, what I have shown, IoT changes the way buildings are designed, constructed, and managed. Is one of the biggest trends in structural engineering. It helps in smart manufacturing by integrating manufacturing equipment with the sensors to gather real-time data or quality and performance. And SHM certainly helps you in periodic monitoring with the updated information and prevent the deterioration of the structural health. Now you can use the kind of sensors which are indicated here, like strain gauge, strand meter, crack meter, displacement sensors, and so on. And from all these sensors, you get data as shown here. You get the local data, you can transmit it to the wireless or you can transmit to the wire. If it is wireless, and then you get into what is called the bandwidth problem. And finally, it goes to what is called the data management system, where you have a central data server, which is having a data processing unit and a data storage system. And finally, to the client server, where the user is sitting to make use of the data. This is the kind of SHM configuration which will be useful for all structures. Now, what are the advanced technologies which are coming in? And digital twin technology and structural health monitoring. Digital twin technology coupled with advanced sensors and predictive analysis, it is revolutionizing the way we monitor and manage the performance of structures. By creating virtual replicas of physical assets, we can simulate real-time behavior, diagnose structural issues, and optimize maintenance strategies. Unmanned aerial vehicle drones, and they can be give the advantage of this technology in the most practical aspects, like pre-planning, detailed survey, and mapping of job site. Particularly if you are going to do the offshore kind of a thing, what Dr. Gomti Naikam was talking about, I think we need all the drone technologies there, and we will be using them extensively. Post-build checks, sales and marketing, 3D scanning of the construction site, and then use the photogrammetry techniques, and drone model can be converted to BIM model and therefore to an FEM model and analyzed after adding corresponding loading data. This is the way we will be in a position to use all these technologies. Now, another one is the 3D printing, which is also known as additive manufacturing. It allows fabrication of complex structures layer by layer, offering unprecedented design freedom. It can be done in concrete and steel structures, although concrete and steel is still coming up, but other materials, it has already come up in a big way. Layer by layer process can give complex geometries, intricate patterns. It gives you design freedom. It reduces the waste of material, and also it can locally source material can be used, which reduces transportation related carbon emissions, what we are talking about. Another material which is commonly now being used in the structural thing is the composites. You all know composites is a combination of two or more physically distinct phases that give properties that are different from its constituents. So when you need high strength to weight ratio, you do it high durability, you need damping properties, you need design flexibility, chemical resistance, corrosion resistance, high impact strength. All of them you can get through the composites. And then multifunctional structures, where you can get acoustic attenuation structures, acoustically transparent structures, embedded systems with sensors, heaters, heating elements, and integral mechanical assemblies like actuation systems can be put inside that. Functional surfaces which can have, for example, the wind turbines, what we were talking about, the blades we were talking of. We are talking about low drag, laminar flow, hydro ice phobic, corrosion resistance. All these things are feasible with these functional structures. And basically, they are all part of the today's smart city systems which are coming using smart materials and so on.
இத்துடன் இன்றைய செய்திக் கதம்பம் நிறைவு பெறுகிறது.